Okay, so I have recorded a video on this question before, but the audio absolutely failed. It disappeared into the abyss. I don't know where it went. So I'm gonna re-record this video, and with improved handwriting as well, obviously, because someone has complained about that, and I have to deal with it. I'd have to improve on my handwriting. But anyways, this is by far the hardest question on this particular paper. It's hard not because of how abstract it is, but more because of how I don't know, just how hideous the calculations are, and you know, one slight, just kind of error could lead you to whatever how far it could be. I do not know, but the calculations are quite hideous. But despite how hideous it looks like, part A1 is absolutely for babies. Anyone with a brain would be able to do that. That is just I plus a till an minus a squared till an plus 1. So that's just I minus a to the power of n plus 1. That's it for part A1. Part A2, obviously we need I minus a. And that is this matrix. Was that a negative? Yep. So this is a positive, negative, positive. And determinant of this is 1 minus cosine theta squared plus sine squared theta, which is 2, 1 minus cosine theta, which is, let's use an identity. So let's write that down over here. Is equal to 1 minus 2 sine squared a. So 1 minus cosine 2a is 2 sine squared a. So this is 4 sine squared theta over 2 because of that identity. Let's edit the positions so it looks more normal on an exam paper. Okay. Obviously, in an exam, you wouldn't be able to do this, but I just want it to look more neat because this is a video. So we have I minus a inverse as sorry about that. We have I minus a inverse as 4 sine squared theta over 2. And then we have the T matrix of that, which means this is negative and this one's positive. So we have 2 sine squared, that's 2 negative 2 sine theta over 2 cosine theta over 2, 2 sine squared theta over 2, 2 sine theta over 2 cosine theta over 2. That's a 2. What am I doing? 2 sine squared theta over 2, which is equal to, after getting rid of the numbers and some of the terms, we have 2 sine of theta over 2, 1. Oh my gosh, I need to improve my handwriting so bad. Okay. 2 sine of theta over 2, 1. And then put in the sines and cosines. The negative should be there. And that's it for part A2-1. This one's very, very easy, in fact. Part A2-2 is more annoying, so let's do that. Obviously, we have the identity in A1, so let's go ahead and use this. Which implies we have as I minus a inverse, I minus a n plus 1. Again, very straightforward. So now we have and then this one is just I minus a n plus 1, which is 1 minus we have 1 minus a n plus 1, the terms inside the matrix, of course, which means we could use the identity here again, which means we'll have a 2 sine n plus 1 theta over 2 here. Obviously, we have this matrix, and then we have the other matrix, obviously, and now we're just using identities. So we have that this should be negative cosine n plus 1 theta over 2 sine n plus 1 theta over 2 cosine n plus 1 theta over 2, 1 minus that, yep, exactly, and then sine n plus 1 theta over 2. Now we have, obviously the 2's cancel out, so we have two types of terms. One of them is this, occupying these two corners. Oh, that's a plus, by the way, cosine of this. So sine A sine B is cosine A minus B minus cosine A plus B. And then we have plus cosine A plus B plus cosine A minus B. So we have cosine n theta over 2 here. Because we get rid of the 2 times because we don't have 2 times in this. And then the other terms occupying the other corners are this. Yep, that's a minus, okay. And I believe that should be sine A plus B plus sine A minus B. So that's sine n plus 2 theta over 2 minus sine n theta over 2, because that's a sine negative n theta over 2, which is just minus sine n theta over 2. And then here we have again sine n plus 2 theta over 2, but then minus, and then we minus another sine n theta over 2. So we have negative sine n theta over 2 here because we don't have the 2 times. Okay, so 2 times and then 1 over 2, we get that. So now we have our final answer. Oh, that should just be an AN. Is this baby right here. And then this one is just the negative version of that. And then this one is a copycat. And we've finished part A2. The calculations are quite hideous, I agree. But it shouldn't be that hard. It should be quite straightforward as well. Part B is just using A2. So obviously, we have the sum of cosines plus 1 to cosine n theta is equal to sine of n plus 1 theta over 2 cosecant theta over 2 and then cosine n theta over 2. So we have, excuse me, that was unintentional, cosine 5 pi over 18 plus cosine 5 pi over 9 to cosine of, is that 25 pi? Exactly, of cosine 25 pi is equal to sine of n is obviously theta is 5 pi over 18, and then n is 25 divided by 5 over 18, which is 90. So we have sine 91 over 2, 5 pi over 18, cosecant 5 pi over 36, and then cosine 90 over 2 times 5 pi over 18, which means we, and don't forget the -1, which means we have sine of 445 pi over 36, cosecant 5 pi over 36, and then cosine of that should be 25 pi over 2. Oops, terrible handwriting again, hold on. 25 pi over 2 -1. This one is 24. Whoops, sorry. That should be 12 pi plus pi over 2, which is cosine pi over 2, which is 0. So this term is 0, so the entire trig function is 0. So we have -1. That's it for part B1. Part B2, we have the sum of cosine squared well, that should be a 7 pi, by the way. So now we have a very, very common formula. This one is extremely straightforward. If you don't know this, you seriously need some help, or consider taking the exams later. And then we could just use this to get an integer, no, not an integer, like a constant plus a sum of cosines. So the constant should be 7 divided by 1 over 7, so 49 over 2, plus the sum of cosine squares. Oh, excuse me, that should be a 2 pi. Obviously, we have 49 terms, which means we have 49 terms, and theta is 2 pi over 7. So we have a sine of 50 over 2 times 2 pi over 7. Wait, let me think. Cosecant of pi over 7, and then cosine of m theta over 2, so 49 over 2 times 2 pi over 7. So cosine 7 pi is cosine 6 pi plus pi, so that's cosine pi, which is -1. And then sine 50 pi over 7 is just sine 7 pi plus pi over 7, which is sine pi plus pi over 7, which is negative sine pi over 7. And obviously, do not forget, we need a -1 here. So now we have 49 over 2 plus 1 over 2 of sine pi over 7 cosecant pi over 7 -1, which means we have 49 over 2. And that's it for this question. And this question is not scary, as y'all can see. And hopefully that helps.